Yeah, hi students. This is the sampling distribution worksheet that I've made for you to be able to answer uh, assignment, week 6 assignment, and this is chapter 15, and it's on sampling distribution. And sampling distribution is based on the central limit theorem, and SRS implies simple random sample. In actual fact, sampling distribution talks about the normal distribution. Okay, talks about the normal distribution, and so this is the normal distribution, and we know that the normal distribution has two tails, negative infinity to positive infinity. On the calculator, we represent negative infinity by negative E99, which is 10 to the power negative 99, and then the positive infinity represented by E99, which is 10 to the power 99. Okay, so when you are doing these normal distribution problems, I don't want you to use the z-score. This is the z-score, okay, and table A. I don't want you to use the z-score and table A. Okay, good. So I'm going to go through these questions now that and show you how to do these problems on your quiz. Now the first question is the Wechsler Adult Intelligence Scale, WAIS. It's a common IQ test for adults. The distribution of WAIS scores for persons over 16 years of age is approximately normal with mean 100 and standard deviation 15. Okay, so when you are doing it, you have to show your work. I mean, if we're in the classroom, you have to show our work, and I'm going to show you. And this, what is here is how to show your work. Now it says that what is the probability that a randomly chosen individual has a WAIS score of 104 or higher? Okay, so the probability, this is how to write this question in symbolic form. Okay, and it says that a randomly chosen individual. Okay, so it's talking about the score of a randomly chosen individual, and this is an individual in the population, and this score is variable, and so represented by X, and the distribution of X, this symbol here represents distribution. Okay, that symbol represents distribution. Okay, and so whenever you see that symbol, you have to know that it's distribution. Okay, and this N here represents normal, this N represents normal. Okay, and then inside we have the mean and the standard deviation. All normal distribution is specified by the mean and standard deviation. Now when you have this problem, you have to draw. So when you draw, the mean is always at the center, and the mean is also the same as the median. Okay, so on your chapter 3 quiz, they gave you the question, they told you the mean and asked you to find the median. You have to know that the mean and the median are the same. And so now when you draw this here, you can draw it. 105 is to the right of the 100. You can put it anywhere. That's fine, and then shade. So it says that 105 or higher. Okay, so that's how you write 105 or higher is greater than or equal to 105. And then you find the normal CDF. I showed you how to do it, on the worksheet for chapter 3. And so you continue like that. And so you put in the minimum value, this shaded region, the minimum value is 105. The maximum value here, okay, here is positive infinity E99. The mean is 100. The standard deviation is 15. And then when you press enter, you get this answer. Okay. Now B says that what are the mean and standard deviation of the sampling distribution of the average, okay, WAIS score, which is represented by S by 4 and SRS of 60 people. Now by the central limit theorem, the X bar, okay, is distributed as normal with mean U, but the standard deviation is the standard deviation of the population divided by the square root of the sample size. Here the sample size is 60. sample size is 60, so you divide by 60. And so you get a standard deviation to be the whole of this instead of just 15. But the mean is the same as the mean in the population mean. Okay, the population mean and the mean of the sample mean are the same, they are equal. So it's 100, but the standard deviation differs a bit. Now, this standard deviation here, we call it, when it's divided by the square root of the sample size, we call it the standard error. Okay, we call it a standard error. Okay, good. Now C says that what is the probability that the average weight score of a simple random sample of 60 people is 105 or higher? Now this question is the same as the first question, but the context has changed a bit. Instead of X, we have X bar. Okay, so here the standard deviation is the one that is changing. Okay, so everything here will be the same apart from the standard deviation, because now we don't have the standard deviation exactly, but we have the standard error, which is the standard deviation of the sample mean. And so you put in the value, and this is what you are going to get. Now this question here, D says that what is the upper 80% of the sampling distribution of the average weight score, okay, of X bar? Okay, so here we are saying that if you are talking about the upper 8% of the distribution for X bar, this is how we write it. We say that probability X bar is greater than a certain number, which is the upper 8%, is equal to 0.8. Okay, it's equal to 0.9. Now, what is A? And this is how you have to draw the diagram first. And over here, I've said that we read probability or areas from left to right in these problems and in the calculator. So always when you are putting in the value in the calculator, whatever value that you have to make sure that you transform it to be a value from the left. Okay, so this value here, you see that it's not starting from, it's starting from the negative infinity. Always the value is starting from the negative infinity. Okay, so it's from starting from negative infinity. So here I have to write negative infinity instead of the left. Okay, negative infinity to the right. So whatever value that you have to transform it to the negative infinity. Okay, from the negative infinity. So here upper 80% is the same as values from the infinity up to where the upper 80% is. A value from negative infinity up to where the upper 80% is. So when you transform it, you subtract either 8 from 100 or 0.108 from 8. Okay, and then that is what you put into the calculator. So when you put it into the calculator, this is what you are going to get. Okay, this is the score you are going to get. I left the answers to 4 decimal place, and that is okay. When you are doing the question, when you are doing the question, is to tell you to answer the question to some specified number of decimal places. Okay, now this question says that what is the 85th percentile of the sampling distribution of the average score? Okay, 85th percentile implies all scores just below 85% score. Okay, just below the 85% score. And so that is it. And this one is already from negative infinity to there. So you don't have to do any transformation, and you have to put it into the calculator direct. And that is what you are going to get. Okay, that's what you are going to get. Okay, so now the last question here says that would your answers to any of A, B, or C be affected if the distribution of weight scores in the adult population were distinctly non-normal? Explain. So as I say that since the sample size n is large enough according to the central limit theorem, 60 is greater than, sample size of 60 is greater than or equal to 30. In actual fact, the central limit theorem says that if the sample size is huge enough, which is 30 or more, then there will not be distinctly non-normality to affect the results. Okay, so that is the answer. And so now the other questions over here, I put down these other questions so that, yeah, I put down the answers so that you can do it on your own. Okay, and then if you have any questions, you can just ask me. You can just email me or text me. You know, my number from the syllabus or on the announcement. My cell phone number is on the syllabus or on the announcement. Okay, so you go through here. It says that what is the distribution? Distribution is the same as the shape. So I've aligned it here for you. Okay, okay. Thank you. Bye. Talk to you another time. Bye bye.